Okay, so for all of those people who haven't heard what I was going to say, we'll just start from here and say the really important bit is to look at your dots, which are your observed point, and the model bit, which is the line. If you have insufficient resources in your model, you won't be achieving your observed data. If you have excess resources, and so your model is over predicting the observed data, that could be because of some biotic constraint or heat shock or some other factor. So, how do I debug a simulation? Basically, I follow through a bit of a decision tree, and that's what I'm going to try and walk everyone through now. So firstly, I look at timing, then water, then nitrogen, then light. So timing is basically phenology. So the question, are the simulated and observed crops flowering, maturing, emerging all around the right time? If they are, well then that's not our problem. If they're not, we need to start looking at anthesis time, at maturity time. And one of the things to remember with this, and I'll step through this a little bit, is firstly go and check the summary file. Every time something happens in APSIM, check the summary file because that is your best guide as to what is going on. So check the summary file and see if the date that is flowering is similar to in your observed date was. At this time you can also check whether there was any water stress or nitrogen stress because this may be upsetting your phenology. Check your observed data and think about how it was measured. Harvesting is not crop maturity. If you're sitting with getting farmer data and they say it was harvested on this date, that won't be maturity because you'll have 2 or 3 weeks after maturity where the crop's been allowed to dry down before they could put a header in. So don't use that as your value. Likewise with emergence. If you're not measuring emergence yourself and you're asking people, oh, tell me when it emerged, if you're driving past at 60 k's an hour, you've usually got 2 or 3 leaves on the plant before the paddock looks green. That is often given as an emergence date. You need to go out early, check your plants and find when they first emerge. Emergence is always important because that's where everything can be measured from. Likewise with flowering, there are many different ways to depict what 50% flowering is. In APSIM with, say, the chickpea model, when 50% of plants have 1 flower is what we declare flowering. I know with many other crops, they're talking about when 50% of the raceme has flowers on it. So find out that you are comparing like with like. One of the other things is deep planting as well. Remember that in APSIM the default is 30 millimetres. A lot of farmers or a lot of crops are planted a little bit deeper than that. The deeper they are, the longer they will take to emerge. And if you are working everything from sowing date, then your flowering date will be out by a few days. Likewise with the height, the depth, especially with dry sowing, a lot of people will plant dry. If you work things from planting date and not from emergence, you will get a different phenological time. Check the cultivar, and if all of that is good, you have more things to check. These are a bit of a double up here, but mostly ensure you are comparing like elements. So ensure that you are comparing kilograms per hectare versus kilograms per hectare, not grams per metre squared. If you're still having problems, look at little components. If you've got leaf weights, see if you are getting the leaf weights right and just see whether it's the stem that you might be getting wrong, and that's why your biomass is going wrong. Other bits are check that you're comparing green leaf against biomass, the green biomass that you're getting in the field. If you're just using the biomass, you are also calculating all the dead material. So make sure you are comparing like elements. Likewise, if you're looking at grain, check that if you're using farmers' yields, there will always be about 10% moisture in those. APSIM works on a dry weight basis, so you're 10% under automatically. I've basically said most of these before. Check the sowing date, check the sowing depth, check the correct cultivar, and if you're confident with all of that phenological data, check the temperature. specifically for, maybe not so much for wheat crops, but certainly for the pulses. Temperature is a big bearing on the way that they perform. If you're trying to model something on the bottom of a hill and you're collecting your metadata at the top of the hill or at the local station, which is usually surrounded by an asphalt piece of ground, your temperatures won't be as low as what you're getting in the paddock, and you can have effects with your phenology then. All right, moving on. So, we haven't got a phenology problem. Let's move on to water. Can we simulate the water? No. Again, first thing, look at the summary file. Investigate the water. I'll go through all of those again here. This is a summary file. I didn't expect it to be as clear as that on this big screen, so I've actually taken that box and created it into a table so you can all read it. Look at the water. In here you can see that water photo and water expansion values start to get stresses. This is a 0 to 1 scale, so when you start getting up around 0.8 and 0.9, there is a lot of water stress occurring. It's all coming in late in this actual simulation, and you can start to see that the water is causing a bit of nitrogen stress as well. So, check the initial values in the summary file. Check that your initial values, that your model is starting at the initial values you think that it is. That is quite a common problem, is that the model starts at a different value. People, when they've put in their initial waters, haven't quite got it to the same as what they observed in the paddock. Ensure that your water is between DUL and drain and lower limit, that your soil is parameterised correctly so that the observed data you're trying to simulate actually lies within the DUL and LL limits. Check your observed data. Soils are incredibly variable, and you usually are only taking a 2 centimetre core and representing it across a paddock. There is a lot of error in soil data. Check your observed data. Rainfall records, a good way to check these, and I guess it relates to the last point here, is look at your rainfall records, look at your soil water. If you've had 10 mils of rain, the soil moisture should probably jump about 10 mils. I've had many soil files come to me where it's rained, we've had 10 mils of rain, and 30 or 40 mils is recorded in the soil. And a lot of times this is because the people are using neutron tubes, and you've got water, slight cracking as the soil's dried, now you've got a mass of water sitting right around the tube when they've gone to read. Give it a few days and the soil will equilibrate back out. But that's often a timing problem. Are you confident in your soil parameters? Are you confident in the evaporation values? Check your evaporation values, check your soil. If all of that doesn't work, and I guess one of the things, is look at your observed data. Now this is data from a Chinese soil, so a really uniform soil. And you can see that my 4 reps there are still quite a lot of variation in my 4 reps. And you can see that the crops and the model's done a really good job extracting water all the way down until we harvested and reached maturity. In this particular crop, when we reach maturity, APSIM declares it and harvested it. It's basically declared dead and moves on, and the water started to fill up. In China, it was hand harvested when it was still fairly green, and the crop kept pumping water out. So I had you have to go and investigate the problem to understand why the model isn't doing exactly what you see in the field. Okay, is there any nitrogen stress? Again, check the summary file. Have you got the N correct? Was there fertiliser additions? That's one of the commonest ones I've found, is that we all get a bit lazy and tend to use the last model that we did and adapt it to the job we're doing today, and you forget to remove things like fertilisers or resets that have snuck in your manager scripts that you may not have thought about today, and suddenly you're getting nitrogen removed or resetting nitrogen to a value that you didn't want when you first thought. The other one is to check your soil pH. So if we look at nitrogen stress, you can see it comes in later in this simulation. There is no water stress. We're just starting to get nitrogen stress. So we can look at that summary file, identify the problem, and go and look at our initial nitrogens. Sometimes it's quite useful to just run a simulation without any nitrogen to just see what the mineralisation rate is for your soil and understand what's happening there. The other problem with that is, Justin's throwing me now.
Sorry, there's a bit of lag and I'm just making sure it's not on our end.
If you're looking at nitrogen, I'll see if I can get some prompts from here. Compare the observed nitrogen with estimates. Yeah, so have a look and just make sure that what's happening is sensible. That you've got, you generally should have a rough idea of if you're getting a 10-tonne yield or a 5-tonne yield, how much nitrogen you really need to get that. And if you can't model it in your head, well, you're not going to be able to model it with a model. So do those rough checks to make sure things are working. Finally, if you still can't get your observed data to match your predicted data, it's not nitrogen, it's not phenology, it's not water. Consider light. In Australia, this is usually not a problem because we're very spoilt, and the Bureau of Meteorology's patch point data sets are everywhere, and they're good. But if you're using your own radiation data or you're collecting radiation data in dusty environments like I was in China, you tend to get a lot of dust on your sensors, and if they're not being cleaned regularly, you can get this dampening of your radiation. The best way to do it is just to do a check against the clear sky radiation, run a clear sky model, check that your data is hitting it regularly. If it's sitting all well below it, you'll know that you need to scale up your radiation to get a good radiation for the model. Still, if it doesn't work after that, time to hit the APSIM helpline and ask some others. Sometimes just talking through your problem, you will find the answer. Sometimes once you say it, someone will say a simple thing that you've overlooked and you'll find the problem. I guess, in summary, to finish up, the model will not predict everything perfectly, and not all factors affecting growth are within the scope of the model. So diseases, heat shock, lots of factors like that, frosts, can all cause the model to do strange things and make it difficult for you to match your observed to your predicted data. Standard line, garbage in, garbage out. If you're trying to put a simulation together and you're not really confident in your initial setup parameters, you can't be really confident in the outputs that you're going to get from it. I guess there's lots of things there, a few more points there that probably you can read just as well, but the main point that I'd really like to bring home and finish with is indiscriminate adjustment of parameters is undesirable. Work through these processes first. Don't jump straight into the ini file and think that you can change RUE to solve a problem. You're just going to create bigger problems and really cause and muck the whole process up. Think about your model, step through it as Agronomy 101, try and figure out what it is you need to understand what's happening. Why do the resources not match the output? Thank you.